Hello, just playing around my Fusion here. I was on the Haas website. Let me go over here. Oops, kind of lost here. I have to change screens here. There we go. And I uploaded the model of the machine we have in class. And so overview, if you're on this page here, right here it says 3D model, and you can download the model. And we got specs. Let's look at pictures though. So this is pictures. This is like meant for somebody's going to buy the machine. So, but we might as well get familiar with it, right? It sits on 4 leveling pads. These are leveling pads. This is the chip conveyor, and this gets inserted inside here. These down here are the controls for pressure of the chuck and the tailstock. So if you see 2, it's got tailstock. All right, next thing we have is the old Haas control pendant with the USB, some switches, and the thing to shut off the beeper and stuff like that. This is the right side view of the sheet metal. This is inside. This is the probe arm that comes down. Ours is air operated, and some are hand operated. And this has the chuck that when you buy the machine, you get one of these 6-inch chucks. So they can make these machines at different sizes. And we're back to the front again. So let's look at some others. We're getting different views here. So here's your chip conveyor. It's got a little motor. When this is running, it drags the chips up here, and you put a barrel underneath. Sometimes the chips will get stuck in here, so you want to make sure, or you drop a tool in here. You know, it has a chip conveyor on it. It has one for reverse if something gets stuck. You don't want to run it in reverse because it's going to dump chips back into the tank, which is part of the casting. Nothing new on this. All right. See if we can get any other views here. How about this one? All right, this one is showing the tailstock. Tailstock's for support, not used unless you're doing that kind of work. This is the turret that we have, and they have variations of this turret. So this has these slots here where you put the tools, and they only occupy half the slot. Half's for a clamp and half's for a slot. Half's for the clamp and half's for the tool. And then this bolt pattern here is for what they call a bolt-on, which gives you a round hole. All right, back of the cabinet. This is the coolant tank, which you cannot see because there's sheet metal around it, but that's the pump, and it's like part of the. No, I'm sorry. You can take the pump out with those handles. I've had to go in there and do maintenance, so. But you have to take that sheet metal cover off to get at that. That's why you really can't check the level of the coolant in the lathe. And we're back to the front again. All right, how about the turret here? So, yeah, nothing new on these pictures. Okay. And of course, you've watched all the videos. They get replacement parts. What's sharp now? What's this say? I had to get some accessories in here. Oh, look at all this stuff. Lube, counterbalance. What are we looking here? Chip removal. So they get replacement parts here. Oh, so if I log into my account, I have the lathes that we bought. So anyway, back to the Fusion. So I downloaded this, right? It's got 2 pedals here, and I turned off a bunch. It actually has. This is like 3 variations of the same machine. So they're labeled pretty good. So this is taking the sheet metal off, right? And this is the where's the door? Door, right there. And I'm going to take away the control. Okay, so this is the innards of the machine right here. Pink. All right. So here is your probing attachment. This is the chuck. This is the head of support. So you can see the similarity to a manual lathe. The motors in here, motors down here. And they have different components here. So on the chuck side, we're going to turn off the chuck. So when you take the chuck off, this looks just like the one we have. This is the bolt pattern, and this little hole right here has got a dowel pin in it. So you got to make sure that's lined up when you put it in. Right here is the taper. So this has to be that, and that has to be clean. This here is called a relief groove right there. And this also has a thread on it. They don't show it on here, but this is part of the drawbar, they call it. So you're bolting it on the taper, and you have to also engage the drawbar. The drawbar goes in and out, and that's what makes the jaws open. So if I take the drawbar away, but that's always in the machine. Oop, let me zoom this out. The drawbar is run by this thing. This is where the hydraulic unit pulls and pushes. Let me turn that back on. See right there, it's attached and not attached. So you're also threading the you're coupling the thing that operates the jaws to this, and we'll give a tool and we'll screw that on there. Or if you're using a collet, the same thing applies. There's an adapter that goes from this to the chuck or this to the collets. But this one's got a chuck on it, right? And so that takes care of the clamping side. Let me zoom this out. And this is the turret. So we got the turret here, right? You can see it right up and close and personal. They've got little numbers on here. And these are all the screw holes for you. So you put a tool here, and you notice they actually got a little groove in there. That they call that a corner relief. So that in order to create a sharp corner, if you relieve the corner, you have a flat wall and a flat wall with no radius interference. That's a common design, and we can do that in fixture making. So, okay, and they don't really show it here, but you only get, I'm getting out of whack. Okay. So this is what they call a slant bed lathe. See how slant bed. This is the x-axis rides up and down these rails. So slant bed lathe saved room because if you tilted this down this way, it would take more space. And the other beautiful thing is all the chips fall down here, and it's like self-cleaning. This area is the z-axis, so this whole head goes back and forth. That's what controls your z-axis, and these are covers. I wonder if I could take the covers off, but these are called linear rails, and they have that's what this rides on for accuracy. And then a motor will pull and push this. That's a servo motor, and there's a motor that pulls and pushes this. So this is where the chip conveyor goes right in through this hole. So you'd be a fool not to have a chip conveyor. And these are called leveling pads right here. So that's how you level the machine with these screw adjusters. So it sits on 4. That's a machine install guy's job. You don't have to do that. Alright, so actually I was in, let's see, I found this part, and where I found this part was in a cam sample. Let me turn this on. This is it says EC400. This is a Haas machine tombstone, and it looks like on here they have it set up. These are the blocks that go onto the CNC lathe. I'm like, oh, I can steal one of those and put it in the machine. So what I did was I went online, I said, how do I just save this? And it turns out you got to be in the design side. And I pick, like I could shut everything off. Oh, tombstone there. I had one block only. So that was like a production setup for making these blocks from two sides. And it turned out if I click on this and say save copy as, it'll just create just that. And that's what this is up here. This is just that block. So what I did over here, right here, I brought it into this design and I aligned it right there. This is on tool position 1, and these are bolted onto this pattern right here. And they line up the crap. Alright, zoom back up again. They have a lip right here. You bring up the block by itself. Okay. So this lip with the corner relief has to be aligned to the face of the turret, so you got to make sure when you bolt this on, you don't want it to be crooked, and your 4 bolts are going to be here. This is going to bolt it on. So BOT's bolt on turret. These side holes are for clamping whatever's in here, and you got holes from both sides. And these things are called reliefs. So when they machine these, they machine inside. So the bore is set up for like, you could put in a boring bar with a bushing, a collet chuck. That's most commonly, so your drills and stuff will go into here in your boring bars. That's going to be your primary. And these holes are meant for coolant, so they're actually attached to this hole, and this is where the coolant is fed through. So the coolant comes through here. It also is connected in the back. So if you want to force coolant down the middle, there's actually a plate that goes over the back here with these screw holes, and you can force it down here. Now normally, if you don't do that, is a plug here, so you can just have coolant coming out the front. So, and there's like little balls that go here, and that's for the nozzles. So, all right, back to this. All right, so here it is. I aligned the bolt-on accessory on here. So this gives you what they call stick tooling and round hole. Let me go to my views here. I'm going to collapse this page. I have some quick views now. Shop view, I call that. And front, top. All right, so when it's in this position here, this tool position is lined up. When you move this down, the tools will be on center to this. So, and when you set up the offsets for the round holes, no matter what position they're in, they're always the same distance from here to here. Always the same. So if you move this turret down to a known position here, you know where to set this tool up. It's like a drill. So that one is like almost like preset. You always have that number. The only difference would be where it goes in this direction, left or right. So this is like getting familiar with the setup. I'm actually going to get a lathe tool to put in here, a cutting tool. So, but I found this quickly. I had this, so I'm gonna either I can upload a design from maybe from Kennametal and insert in a line here. So I could actually build this out to be looking like a real machine, or actually put a chuck in here. So I don't know really much about this. So when I brought this in, it was like out and floating out, and I did an alignment. I aligned it to this. So right now I think it's still movable. it's not what they call what do they call it? Grounded, I think it's called. I'm a real rookie at this stuff, so. But I like, this is pretty cool stuff. I'm learning to just use this for my own benefit, but and they got different colors and everything. It's kind of cool. All right. I wish I could make this move around. Maybe I could figure out how to do that later. But I think this says a lot about the lathe. How do you? I think that's why a lot of schools use the tool room lathe, because that looks more like like a normal lathe. So the tool room lathe. Let's see now. Let's get out of the ST series here. Go back one click. Models. Alright, so these are your models, different sizes, right? This one has Y-axis. I'm going to pull that demo up later, but let's large through bore. Oh, this is just the normal ones. Tool room lathe looks like a normal lathe, but I think the slant bed lathe is the way to go. All right. So I was actually in here, how to save components from an assembly file as individual files. And it told me exactly what to do. Save, copy as. That was easy. All right, so I looked up the models. I downloaded the machine. Actually, I downloaded a 4-axis, so I want to learn about the 4-axis. But in this case, I had this was this assembly here. This was what we call a tombstone on a horizontal mill. See, this is a plate that bolts onto the pallet. So in your machine, I'll have to load a whole EOC machine. The Z-axis goes in this right to left direction. So it's going to machine these. So of course it can't machine everywhere, so it's machining one side and machining the other. Also, the benefit of a 4-axis horizontal mill is you can machine this side, and this side. And when they did this side, they turned it 90 degrees to get you couldn't get those drilled holes. So now you can get the drilled holes. On this side, you can put that bolt pattern on the top and machine the. So you could turn this at the angle you want and just face mill those. You wouldn't 3D machine those. You would actually go at it from this direction. So let's go to manufacturer. This is getting kind of deep. This is, but I thought I'd show you this anyway. Let me generate. I'll close up these two. See if we can, it's pretty deep. Alright, this has just got one simulation here. And what they do, they use a pattern. Pattern will do all of them. It's right there. It's like duplicating the same. Simulate. Stock. This is stock. Toolpath. Go. Right. Machining. So it's when it duplicates, it's just doing the other 4. Then you can sort it by which tool do you want. Do you want the same tool, or do you want to do this one complete? So you can see it's doing that step. Let's put it on transparent. Yeah. So it's being held into this vise with these little clamps right here. And this is a double vise. So this is the fixed jaw, and this is movable, and that's movable. And right up here, I see the little hexes. This is where you would tighten it up. So you notice now it's coming from this point of view. So this whole turret would turn. Speed up a little bit. Oh. machine that side. So now it just duplicates the same operation. That's what the pattern feature is for. Now it's doing all this smaller work. So it's milling. We think of milling from this point of view, right? Z-axis being this direction. But you could not do the sides. So this is getting a little bit. Now if we had a 4-axis in our, which we do, and you design something like this, you could do, and you probably would have to support it on this end. That's the only problem with, this is pretty big, and it's going to want to bend. That's what the nice thing about the horizontal is, facing up, it's not going to bend. This is be very strong and rigid. But whatever thing you're bolting onto, the rotary table would be strained. So a lot of people would put support on this end. So you could do this kind of work on a vertical machine. So that's looking at from this point of view. So Z-axis would be this way. All right, that was pretty lengthy. So I'm going to stop this right here. Enough machine demo, but I think when you look at it from this view, you can kind of envision it a little better. All right, talk to you later.